Welcome back. I'm audible to you.
Yes, sir.
Okay. So we will start with now Unit 4, that is the most important part of it, that is measures of variation and skewness. What is the significance of measuring variation? Word itself says variation means deviation. Measuring variation is a significant for some of the following purposes. Measuring variability determines the reliability of an average by pointing out as how far an average is representative of the entire data. Another purpose of measuring variability is to determine the nature and cause variation in order to control the variation itself. Third one,
Player add
measure of variation enables comparison of two or more distributions with regard to their variability. What are the properties of good measure of variation? A good measure of variation should possess, as far as possible, the same properties as those of good measure of central tendency. Following are some of the well-known measures of variation which provide a numerical index of the variability of the given data. The first one is range. Second one, average or distribution. Third one is quartile deviation or semi-interquartile range. Fourth one is standard deviation. First of all, we will start with the range. Range is the difference between the highest and the lowest value of the distribution. You can see here there are numbers 2, 3, 4, 5, 6, 7, 8, 9, 10. Range is basically the smallest number is 2 and the largest number is 10. The difference between the largest and the smallest is 8. That means 10 minus 2. The range is the simplest measure of variability to compute. However, it does not use all the data. As the sample size increases, the range also increases, but the range can never decrease. Now see, if we have 2, 3, 5, 10, range is 8, and if we have 2, 3, 4, 5, 6, 7, 8, 9, 10, again the range is 8. Range does not give any information about the nature of the distribution of values. What is coefficient of range? H minus L upon H plus L. H means highest value minus the lowest value upon the summation of highest and lowest. Now comes quartile deviation. You are aware of quartiles? Quartile deviation is also known as semi-interquartile range and is computed by taking the average of the difference between the third quartile and the first quartile. That is, quartile deviation is Q3 minus Q1 by 2, where Q1 is the first quartile and Q3 is the third quartile. And the relative measure corresponding to quartile deviation is called as coefficient of quartile deviation. That is Q3 minus Q1 divided by Q3 plus Q1. Quartile deviation is superior to the range as it is not based on the extreme values but rather than the middle 50% of the observation. Another advantage of quartile deviation is that it is the only measure of variability which can be used for open end distribution. The disadvantage of quartile deviation is that it ignores the first and the last 25% of the observation. Average deviation. The measure of average deviation is an improvement over the previous two measures in that it considers all observations in the given set of the data. This measure is computed as the mean of deviations from the mean or the median. All the deviations are treated as positive regardless of the sign. That is why a mod sign is used. That is summation of x minus x bar mod upon n. That means it will always have a positive value. This is deviation from mean. And if it is the deviation from median, that will be summation mod of the difference between x minus median divided by sum of the observations. The relative measure corresponding to the average deviation is called coefficient of average deviation. And if average deviation has been computed from median, the coefficient of average deviation shall be obtained by dividing the average deviation by the median. If the deviation has been calculated from mean, the mean will be there used in the denominator, and if median is used, so in the formula, mean will be replaced by median. And we have this is the advantage in taking the deviations from median because the sum of the absolute deviations, because we are ignoring plus and minus sign, the median is always is minimum. In actual practice, however, arithmetic mean is more popularly used in computation of average deviation. Although the average deviation is a good measure of variability, it is its use is limited. If one desires only to measure and compare variability among the several sets of data, the average deviation may be used. The major disadvantage of average deviation is that it lacks of mathematical properties because you are ignoring plus and minus signs. This is more true because non-use of signs in its calculation makes us algebraically inconsistent. Then comes the highly and the most important concept, standard deviation and variance. Again, depending upon the nature of the data provided to you, you have to decide which formula of standard deviation will be used. The standard deviation and variance measure variability upon the mean, about the mean. Standard deviation is used in other statistics and it's the most stable of the variability indices. If one reports the mean as measure of central tendency, then standard deviation is also required. The standard deviation is good for interval or ratio data. However, the standard deviation is affected by the extreme values. Approximately 68% of the measurement will fall within one deviation of the mean. 95% falls within the two standard deviation, and 97.7% falls with three standard deviations. The concept of standard deviation was introduced by Carl Pearson way back in 1893. Now see formula number 1 and formula number 2. In general, in terms of symbol, the standard deviation for n individual observations. It is denoted by sigma equal to under root summation the difference of x minus x bar whole square divided by n. Keep one thing in mind. Don't cancel this 2 square by this under root because you are calculating this part individually. Nothing to do with this under root. When this calculation of the number will be divided by n, then under root has to be. Yes, but Puchia, what is your question? I'm audible. What is your question?
Sir, you are audible. I think she raised by mistake.
Now, somebody raised the question. Now I'm asking what is the problem? No one should respond to it. For a group frequency distribution, you can see over here, f is included in this. This is the basic difference and we will be using This if the data is small, and if data is big, third formula will be used. Here comes the third formula. Sigma is equal to under root summation fx square divided by n minus summation fx by n whole square. If you are using deviation, data is too big, then you will be using d is equal to x minus a into upon I. In that case, x will be replaced by e. Summation fd square by n minus summation fd by n whole square into I. Now keep one thing in mind, into I is outside the under root. It's not in the under root. And variance is the square of standard deviation and it's denoted by sigma square. So sigma square is equal to variance. So sigma will be under root variance. Now see, a table below provides data for the library membership of children in different age groups. Find the mean and standard deviation of the membership. Here three columns are given to us. How this column will be used. First is age group 5 to 7, 8 to 10, 11 to 13, 14 to 16, 17 to. Madam Akansha, what is your query? Membership fee is given to you and number of children, that is frequency is given to you. आपसे उसने relation पूछा है between membership fee and the number of children. So we will be using membership fee as X and number of children as F. First of all, we have to calculate Fx and then we have to calculate Fx square. These two columns will be generated by squaring and by multiplying. So we will be getting three numbers at the bottom. There are 30 children and summation of Fx is 1290 and summation of Fx square is 59,900. Mean is simple. 1290 divided by 30 is equal to 43. Standard deviation is summation of Fx square divided by n minus summation Fx upon n power 2. See, 59900 divided by 30 minus 1290 divided by 30 whole square. After calculating all these values, we will be, or simplifying it, we will get 12.515 as the standard deviation. Coefficient of variation. For distribution having the same mean, the distribution with the largest standard deviation has the greatest variation. But when considering distributions with different means, decision makers can't compare the uncertainty in distribution only by comparing standard deviations. In this case, the coefficient of variation is used. That is, the coefficient of variation for different distributors are compared and the distribution with the largest coefficient of variation value has the greatest relative variation. That means the coefficient of variation is basically given by sigma upon x bar into 100. Because it is quantitative analysis, so we have to remember some formulas and some concepts. Now comes skewness and kurtosis. Skewness refers to the symmetry of a distribution. Symmetry means that for a given deviation from a central value, there are equal number of observations on either side. If a distribution is skewed, it will have a longer tail either towards left or right. This skewness is departure from symmetry. In a symmetrical distribution, mean, mode, and median are equal. If a distribution has long right tail, it is positively skewed, and if it has long left tail, then it is negatively skewed. Now see, because this is a relation between mean, mode, and median. If all the three values are equal, it will be symmetrical. And now this is a bell-shaped graph. First one is, figure one is bell-shaped graph. It is for a symmetrical distribution. A symmetrical distribution is that distribution in which all the three central measures are equal. That means mean is equal to median is equal to mode. But if mode is less than median is less than mean, it will be positively skewed. And if mode is greater than median and median is greater than mean, it is negatively skewed data. These are the three diagrams. Now comes coefficient of skewness. Be careful, see to these three formulas. These three formulas are for a particular problem only, depending upon the data given is in which form. First formula, skewness, coefficient of skewness is x minus m naught upon sigma, which is equal to mean minus mode upon standard deviation, which is equal to q3 plus q1 minus 2 times of q2 upon q3 minus q1. Depending upon what is given to us in the problem and what has been asked to calculate, we will be using the formula accordingly. Coefficient of skewness in terms of mean, mode, median, and standard deviation. It is 3 times the difference between mean minus median divided by standard deviation. If Sk is greater than 0, it is positively skewed. If Sk is less than 0, it is negatively skewed. And if Sk is equal to 0, it is symmetrical. Now, second one is Sk is equal to Q3 plus Q1 minus 2 times of median upon Q3 minus Q1, which is a formula of coefficient of skewness which was given by Bolle, and it is more appropriate. That means we use Q3. Now see, this is a problem. These four columns are given to you. Don't be confused, it is a single problem with having 7 class intervals. We have to calculate Carl Pearson and Bolle's method coefficient of skewness. So we will be transforming this data into our normal form. Here it comes. Column number 1 and column number 3 is given to you. Column number 2 has been calculated. This is the mid value. The difference between 10 and 12 is 2. That means from 11 you will be adding 2. 13, 15, 17, 19, 21 and 23. Now move to fourth value. We have to calculate D. D is equal to x minus 17 divided by 2. What is 17? From where you got 17? Is there anyone who can tell me from where we got 17?
It's the middle value, sir.
The middle value
Middle value of what?
x.
Hmm.
That's the median, sir.
Correct. Now we have to calculate FD and FD square. D is 0 for the central value, and above it, it is -1, -2, -3, and below 0, it is +1, +2, +3. We have to calculate FD and FD square, and we have to sum them up. FD, summation FD is -9, summation FD square is 251, and summation of N, that is for summation of frequency, is 100. Go back to the formula of mean. X bar is equal to A plus summation FD upon N into I. This is 17 minus 9 by 100 into 2, which is 16.82. This is the mean. Is this understood to you?
Yes, sir.
Now comes mode. And this standard deviation, summation FD square upon N minus summation FD by N, square into I. After calculating, you see 2 is outside the class interval. The difference between the upper limit and the lower limit 2 is outside the under root. At the last, it will be calculated. It will be multiplied or it will be used. It is 1.5817 into 2, which comes out to be 3.1634. This is the standard deviation. Okay, SK is equal to mean minus mode upon SD. So it comes out to be 16.82 minus 18.5 divided by 3.16, which is a negative value. This value of coefficient of skewness indicates that the distribution is negatively skewed, and hence there is a greater correlation between towards the higher profits. Now, how to calculate Bowley's method? For Bowley's method, we have to calculate Q3 and Q1. Yes. Now, see. You have to calculate Q1. Q1 means n by 4th term in the cumulative frequency. Just any one of you, let me know how cumulative frequency is calculated in this problem. Any one of you.
Adding to the next value, sir. 8 plus 12 is 20. And then 20 plus 20 is 40. 40 plus 25 is 65. 65 plus 15 is 80.
That means your n is 80. You have to calculate Q1. Q1 is n by 4. Size of n by 4th observation. So that means 80 by 4 is 20th. So in which class this 20 lies?
Below 50.
It is in 50 to 60. 20 is in 50 to 60.
Below 50, sir.
Huh?
50 to 60.
That is what I'm saying. And Q1 is L plus n by 4 minus PCF upon F into I. Your L is 50. N by 4 is 20. Cumulative frequency of the preceding class, 8. And frequency of the model, this median class, that is 12. And what is the difference? 10 into 10. See, Q1 is 60. Okay. Q1 is 60. Now, Q3 will be calculated. That means now we will be using 3n by 4. For calculating median, we have to do n by 2. N by 2 comes out to be the 40th observation. In which class 40 lies? 40 lies in 60 to 70. In that case, your L will be 60. 60 plus 40 minus 20 upon 20 into 10, which comes out to be 70. Q3 will be 3n by 4. 3n by 4 comes out to be 60. 60 minus 40 divided by 25 into 10. That is 78. What is the formula for calculating coefficient of skewness? Q3 plus Q1 minus 2 median upon Q3 minus Q1. Straight away put up the values. You will get negative 0.11. That means it is negatively skewed. This 3 and this 3n by 4. This 2n by 4. And this is n by 4. Is that clear?
Yes, sir.
Now see, the value of coefficient of skewness indicates that the distribution is slightly skewed to the left, and therefore there is a greater concentration of the sales at the higher values than the lower values of the distribution. For Carl Pearson formula, it comes out to be negative 0.11. The value of coefficient of skewness indicates that the distribution is negatively skewed, and hence there is a greater concentration towards the higher profit. Now comes quartile deviation of semi-interquartile range, that is Q3 minus Q1 divided by 2. And the coefficient of quartile deviation is Q3 minus Q1 upon Q3 plus Q1. Quartile deviation is a superior to the range as it is not based on the extreme values, but rather than the 50% of the observations. Another advantage of quartile deviation is that it is only measures of variability, which can be used for open-end distribution. The disadvantage of quartile deviation is that it ignores the first and last 25% of the observation. Average deviation, if it is from mean, it is mod of x minus x bar divided by n, and if it is from median, it is x minus median upon n. We will see to a problem. Okay. Now we move to block 2, that is probability and probability distribution. It includes 4 units: concept of probability, discrete probability distribution, continuous probability distribution, and decision theory. So we'll start with basic concept of probability. Probability means what? What do you mean by probability? Whether the thing will happen or not. Two things are there. The probability is concerned with random experiments. Data demands an inference to be drawn, and statistical inferences are never certain. Statisticians would be prompted to use prefixes or suffixes as likely or almost likely. What is the now we will see the basic concept of probability. Probability and its concept are thus very important to interpret the inferential statistics. The theory of probability is a study of random experiment. In a random experiment, set of all possible outcomes is always known, but it is not possible to predetermine the outcome. For example, the probability of a coin toss resulting in either heads or tails is 1. The probability of a coin toss resulting in head is 0.5, because the toss is equally likely to result in tails, and there are only 2 possible outcomes, either head or tail. Probability deals with the calculating the likelihood of a given event occurrence, which is expressed as a number between 1 and 0. An event with the probability 1 can be considered as a certain event, and an event with a probability of 0 can be considered as an impossible event. In other words, with the help of probability, we can assign a measure to the uncertainty with the occurrence of each possible outcome of a random experiment. Probability of getting a red card from pack of cards. How many cards are there in a pack of cards? Any one of you?
52.
56, 52.
Oh,
Fif-
okay.
13.
52.
13, sir.
52.
52 are there. How
52.
many are red? मैं आपको अभी I will make you clear every concept. Just answer to my questions. How many black cards are there?
13.
26.
13 plus 13, 26.
26.
Then what is the probability of getting a red card?
1 by 2.
5.
How? 1 by 2? How?
0.5.
26 by 52, sir.
26 by 52 because there
26, 26 for black card divided by 52.5.
are, okay. That means probability is total favorable cases upon total number of cases. That is the basic formula for occurrence of an event. Total favorable cases upon total number of cases. Now, what is experiment? An experiment, the term experiment is used in probability theory in much broader sense than in physics or chemistry. Any action, whether it is tossing of a coin, measurement of a product's dimension to ascertain quality, or the launching of new product in the market, constitute an experiment in the probability theory terminology. How comes sample space? It is set of all the possible outcomes of an experiment is defined as the sample space. Each outcome is thus visualized as a sample point in the sample space. Thus, said head and tail both defines the sample size of a single cost of a coin. आप एक coin को toss करेंगे, what you are going to get? Either head or a tail. What are the total number of outcomes? Head or tail? 2. Getting head on a toss is 1. 1 by 2 is the probability. Event. An event in probability theory constitutes one or more possible outcomes of an experiment. An event can be defined as subset of sample space. Experiment is toss of a coin, sample space is tails or head, and getting a tail on a toss is an event. Now the definition of probability. There are two basic definitions what we use in mathematics. That first one is classical definition of probability, and the second one is axiomatic definition of probability. Before defining probability, several other definitions need to be understood. First one is random experiment. An experiment or a trial whose outcome is not perfectly predictable, but for which the set of all possible outcomes is repeated trial is known as random experiment. For example, toss of a coin. Outcomes are head or tails. और तो कुछ नहीं आएगा, सिक्का खड़ा नहीं होगा. Random variable. A random variable is an assignment or numbers to possible outcomes of a random experiment. For example, considering tossing of 2 coins, the number of heads showing when the coins land is a random variable. What will happen? Either head will come or tail will come in the first one. Similarly, in the second one, either tail or head will come. तो total number of possible outcomes कितने हो जाएंगे? इसका एक mathematical rule है. You are tossing 2 coins at a time simultaneously. That is 2 raised to the power 2. That means total number of outcomes will be 4. Now your question arises, how 4? First one, TT, tail on both. Second one, tail on first and head on second. Second one. Third one is head on first, tail on second. Third one. And both heads. Not more than anything, more than is possible. This is the sample space. Outcome space and event. An outcome space is a set of possible outcomes of a given random experiment, and it is denoted by capital letter S. An event is a subset of outcome space. An event is determined by a random variable. Outcomes are the set of all possible results of a random experiment. Exhaustive events. Exhaustive events are a set of events in a sample space such that one of them compulsorily occurs while performing the experiment. In simple words, we can say that all possible events in a sample space of an experiment constitutes exhaustive events. For example, while tossing an unbiased coin, there are two possible outcomes, head or a tail. So these two outcomes are exhaustive events, as one of them will definitely occur while flipping up the coin. That is what I said. It's not going to stand. Disjoint or mutually exclusive events. Two events are disjoint or mutually exclusive if the occurrence of one is incompatible with the occurrence of other. If they can't both happen at once, eventually two events are disjoint if their intersection is an empty set. Independent event. Two events A and B are statistically independent if the chance that they both happen simultaneously is the product of chances that each occurs individually, or knowledge that one event has occurred does not give any information about whether the other event has occurred too. For example, getting ahead on the first throw and getting ahead on the second throw are two independent events. सेकेंड थ्रो के ऊपर हेड आ रहा है तो फर्स्ट हेड से उसे कोई लेना देना नहीं है. Equally likely events. Two events are said to be equally likely if the occurrence of one of these is expected in preference to others. Equally likely events are those events which have equally probability of occurring. That will be a case of toss of a coin. When a toss an unbiased coin, the probability of getting ahead is 1 by 2 and the probability of getting tail is 1 by 2, which is an equally likely event. When we roll a die, the probability of getting 1 is 1 by 6, probability of getting 2 is again 1 by 6, 3, 4, 5, 6, every event has a probability of 1 by 6. However, the probability of drawing one red ball in a bag of 3 blue and 2 red balls is 2 by 5 because total number of balls are 5 and you are drawing a red ball. Red ball are 2, that means 2 by 5. The probability of drawing a blue ball will be 3 by 5. We can clearly see that these events are not equally likely to occur. Mathematical definition of probability. If n is the number of equally likely, mutually exclusive, and exhaustive outcomes of a random experiment, out of which m outcomes are favorable to the occurrence of an event A, then the probability that A will occur, it is denoted by P within brackets A and is given by number of outcome favorable upon total number of exhaustive outcomes. Or we can, other words, in the simple form, we can say that probability of an event is favorable cases upon total number of cases. All these approaches, however, share the same basic axioms. These axioms are fundamental to probability theory and provide us with unified approach to probability. The axioms are the probability of an event A, which is written as PA, must be a number between 0 and 1. That means both values are inclusive. That means mathematically it will be 0 less than equal to PA less than equal to 1. Probability of event will always be between 0 and 1. The probability of occurrence of one of the other of all possible events is equal to 1. If S denotes the or the set of all possible events, we write PS is equal to 1. Thus, in tossing a coin once, head or a tail is 1. If two events are such that occurrence of one implies that the other cannot occur, then the probability that either one or the other will occur is equal to sum of their individual probabilities. That means we can say in mathematical statistical form, probability of success plus probability of failure is equal to 1. Probability of success plus probability of failure is equal to 1. It can never be greater than 1 or it can never be less than 1. Now, this is a very peculiar problem which is related to a general concept. What does and how does this is interpreted and a Venn diagram is used. In survey, it was found that 21 people liked product A, 26 liked product B, and 29 liked product C. If 14 people liked product A and B, 12 people liked product C and A, and 14 people liked product B and C, and 8 liked all the three. We have to find how many liked product C only. This seems to be a very complex problem, but in business part, we come across where we have to make or a decision or we have to come to a conclusion. Now, in these sort of problems, we have to draw Venn diagram, and no such concept of probability is being used. There are three events A, B, and C. Product A, B, and C are there. We will go back. How many people are there? 21 people liked product A. So it will be denoted by NA. Similarly, NB 26, NC 29. We see that there is a combination of there are 14 people who liked A and B. If liking is there in sets terminology, it is denoted by intersection. That means N A intersection B is equal to 14. Similarly, N C intersection A is equal to 12 and N B intersection C is equal to 14. And in the last, you can see that there are 8 people who liked all the three products. That means A intersection B intersection C is equal to 8. Now we will be drawing Venn diagram. There are three parts A, B, and C. You can see that they have been merged. Why they have been merged? Because there is intersection of A and B is there, intersection of A and C is there, intersection of B and C is there, and at the center there is the intersection of A, B, and C. All are there. Now, this data was given to you and this has been generated. And A intersection B is 14. Why? This 14. A intersection C or C intersection A is 8 plus 4, 12. And B intersection C is 8 plus 6, that is 14. And all the three is 8. It has been seen that the number of people who like product C, where is product C? 4, 8, and 16. And how many C are there? 29. 29 minus 4, 8 plus 29 minus summation of 4, 8, and 6. That means there are 11 people who like product C. We have not used any concept of probability. It is simple, mere analysis. Now, consider your locality where out of 5,000 people residing, 1,200 are above 30 years of age and 3,000 are female. Out of the 1,200 who were above 30, 200 are females. Suppose after a person is chosen, you are told that the person is a female. What is the probability that she is above 30? Read this question very carefully. What does that indicate? What is given and what has to be found? No doubt this is a problem related to probability. Because in the last line it is written, what is the probability that she is above 30? There is a person chosen is about above 30 is A, and B is a person chosen is a female. There are two things together. Problem is focused on event A, given that B has occurred. If we denote the event by A by B, so we have to find P A by B. Out of the 1,200 persons who are above 30, 200 are female. Right? This is given in the problem. Here, out of 5,000 people in the locality, 200 possesses the characteristics of being female as well as above 30. Two events are happening. Event A and B can be defined as AB. Event that a person is both a female and above 30 years of age. What is PA is equal to 1,200 by 5,000 and PB is 3,000 by 500. We have to calculate PAB. So what we will do? We have to calculate PAB. This is given to you PAB. 200 by 5,000. To find the probability that given a female has to be chosen, she will be above 30. We see that out of 3,000 females in the total population, only 200 are above 30. That means PA by B will be 200 by 3,000. But you were being asked to calculate PA by B. That means 200 by 3,000. By any mode, you are going to get the same answer. In the last line, this part, different concepts have been used, but this is the answer. If you use simple basic risk formula, you will get this. And if you use mathematical probability analysis, so you will get this answer. But on simplification, answer will be 200 by 3,000. What are the axioms of probability? That is very simple to understand. Probability of an event will always be between 0 and 1. Probability of an event will always be a non-negative number, less than or equal to unity. Second axiom is sample size must be equal to unity. This is not required. This is one of the most important part in probability, that is Bayes' theorem. Before starting the theorem, it is imperative to know about prior and posterior probabilities. Prior probabilities, these are the probabilities which are assigned to events on the basis of conditions, past experience or judgment. And the posterior probabilities are these are the revised probabilities in the light of some additional information. See to it. Mathematically based theorem is written in this form. It states that if A, B are two mutually exclusive and collectively exhaustive events, and C is another event defined in the context of the same experiment, then given the values of PA, PB, PCA, and PCB, the conditional probability PA by C. See the difference? Here we have written PC by A, and we are asking for PA by C. What we will be doing? We will be multiplying this PCA by the probability of PA in the numerator, and in the denominator we will be writing PCA by A into PA plus PCB into PB. And similarly for P by C, we will be changing A by B, and the denominator will remain the same.
Sir, can you please repeat previous question? I could not understand.
Which one?
Previous to this one?
What was that?
Yes, yes. This
This one.
one, this one, this one, this one. Yes, sir.
Read the problem carefully. Consider your locality where out of 5,000 people residing, 1,200 are above 30 years of age and 3,000 are female. Out of the 1,200 who are above 30, 200 are female. Suppose after a person is chosen, you are told that the person is a female. You have to find the probability that he is above 30.
Okay, sir.
So what you have found? There are two events happening. First one is A. If we choose a person chosen is above 30. Because in
Yes.
the last line it is written that she is above 30. तो पी ए तो हो गया आपका 1 above 30 और पी बी क्या हो गया choosing a female. Correct? Problem
ठीक
is
है सर.
problem is focused on event A, given that B has occurred. So mathematically that comes out to be A by B. Out of
Okay.
12 persons who are above 30, 200 are female. This is again given in the problem.
Okay, sir.
Out of 5,000 people in the locality, 200 possesses the characteristics of being female as above 30. This is again given in the problem.
Yes, sir.
But now where is the problem? What you have been asked? Event AB can be defined as PAB. Event that a person is both female and above 30. But question is will remain the same. You have to calculate PB, PAB. What is that?
Person is both female and above 30.
Above 30. What will you do? See to it.
So how this formula is being used, sir? I could not. I am not.
Which formula?
This P A by B equal to uh,
200 by 3,000. Your question is, that is a basic of probability. That is why I've written over here. This is how it is evaluated.
Sir,
PA by B, PAB
sir,
by P.
sir, 200 is defined as uh, above 30 and female. Is it so?
Yes. PA by B is equal to PAB by PB. Now PAB is 200 by 5000 and PB is 3000 by 5000. When you are going to solve it, what you are going to get? 5000 by 5000 will be cancelled. You will be left by 200 by 300.
Okay.
So if you don't mind, can I say something?
You are most welcome, madam.
Actually, we already have 203,000, both the figures in the question only. So why do we need to solve it? It would be more interesting if we have to find it for the male one. Otherwise, what is the point of using the formula? Because we don't need to calculate like how many men are there or
Madam,
3,000 by 5,000. That is just increasing the process.
no. That is not the thing. I have chosen this problem because students have fear of mathematics.
Okay, okay.
I
Because
just
I
want you to
come
know.
from non-medical stream, so I was like, what's the point when we already have
No, no,
200,000 in the question only?
no, I tell you, I don't
Yeah.
know what is your basic qualification is. There will be many
Sir,
engineers.
actually,
There
Sampriti
will be
has a confusion here. Sampriti, it is not that number of female is given. It is a probability that female will be chosen is the question.
this is how the problem is. How
Yes.
do you how do you see the problem?
Okay.
In the first problem, I didn't use anything of probability. I just used it normal common sense. In the
That's
second case,
good. That
I
was
simply used again the common sense, but in terms of probability.
okay.
Okay,
Yeah. For sure. Thank you.
thank you. This has been done. I was doing the most important, the most confusing part, that was Bayes' theorem. See the statement. It states that A and B are two mutually exclusive and collectively exhaustive events, and C is another event defined in the context of the same experiment. Now, three things are there. Given that the values of PA is given, PB is given, PCA, C by A is given, and PC by B is given. Everything is given. Now condition comes. What is the probability of PA by C? So see the formula. See the numerator of the first one here. Reverse this into A, probability of A, divided by this one plus probability of A into probability of CB. And if this is changing, again numerator will change by B. When you will be adding these two, you will get 1. This is Bayes conditional theorem, which is Bayes theorem. We'll see if I do have a, here it comes. Now see, how interesting is the problem. A car manufacturing factory has two plants, X and Y. Plant X manufactures 70% of the car. So it's understood that plant Y will be making 30% of the cars. Manufacturing of the car event is manufacturing of the car by two plants. So we will take PB1 for the first plant, that is 70%, that is 7 by 10. And PB is remaining 30%, that is 3 by 10. Keep one thing in mind. In Bayes' theorem, try to keep your denominator as simple as possible. I have reduced this 70 by 100 to 7 by 10 and 30 by 100 to 3 by 10. My denominators are same. अब आप में से कोई ये भी कहेगा कि सर अगर हम 70 by 100 ही रहने दें तो भी तो डिनोमिनेटर सेम रहेगा, तो अभी फर्क पता लग जाएगा. Now what is happening? 80% of the cars of plant X and 90% of the car of plant Y are of standard quality. That means, see the change. PE by V1. Plant 1 is 80 by 100 and PE by V2 is 90 by 100. Okay? 8 by 10 and 9 by 10. What is the problem? A car is chosen at random. It is found to be of standard quality. What is the probability that it came from plant X? तो आपको करना क्या है? quality standard car was drawn from lot? It is, the probability has been asked that it has been manufactured by plant 1. So this is the probability it has been manufactured by plant 1. Under what condition? PB1 into PE by V1 upon PB1 into PE by B1 plus PB2 into PE by B2. All these values are given to you. This is 7 by 10 into 8 by 10 upon 7 by 10 into 8 by 10 plus 3 by 10 into 9 by 10. ये सब सम होगा. कैलकुलेट करने के बाद you will get 56 by 83. अब इसी प्रॉब्लम को मैं हल एक एक्सटेंड करता हूं और what is now second part of this, what is the probability that drawing a quality car from plant 2, तो आपके इस गेटअप में चेंज क्या हो जाएगा ये बता दीजिए बस मुझे. कोई भी प्लांट 2 चाहिए. ये प्रॉब्लम थी प्लांट 1 की, इसको प्लांट वाई कर देता हूं मैं तो प्लांट 2 हो जाएगा आपका. न्यूमरेटर में क्या चेंज होगा ये बताइए.
न्यूमरेटर में दूसरा वाला टर्म आ जाएगा सर.
कौन कौन से कितने टर्म आएंगे?
न्यूमरेटर
टर्म आपके सामने लिखे हुए हैं.
हाँ, PB2 इंटू PE बाई B2 हो जाएगा सर न्यूमरेटर में.
ये रहा, ये लिखा हुआ है यहाँ, ये रहा.
हाँ, राइट.
ये न्यूमरेटर यहाँ चला जाएगा, डिनोमिनेटर यही रहेगा.
यस.
इसका आंसर विदाउट कैलकुलेशन बता दो मुझे कोई.
ये 1 माइनस 56 बाई 83
है जी.
सर. ये
Answer is 27 by 83.
What you did without using the formula?
Sir, we did 83 minus 56. That is numerator, and denominator will be remain the same 83.
That means what you do, probability of success plus probability of failure is equal to 1. Mathematically आपने क्या किया? You did 1 minus 56 by 83. यही किया है ना आपने?
यस सर.
Now comes discrete probability distribution. If all the possible outcomes of the experiment together with their chance of occurrence were made available. Number 1. Number 2, if betting on head to find that a toss of 3 coins may result in 0, 1, 2 or 3 heads with respective probability of P 1 by 8, B by 8, B by 8 and 1 by 8. Don't be worried about these numbers. I will show it to you in the problem how these numbers came. This representation of all possible outcomes and their probabilities is known as probability distribution. Suppose you are interested in number of heads in tossing of 12 coins. You need to apply a discrete probability distribution, and discrete probability distribution can be used in decision making. Outcome of the toss of 3 coins were expressed in terms of number of heads. What H will receive? एक हेड के एक टॉस के अंदर कोई भी हेड नहीं आएगा. 1 head will be there, 2 head will be there और 3 heads will be there. इससे आधे हेड नहीं हो सकते क्योंकि आपने 3 coin toss किए हैं. This uncertain real variable H, which assumes different value depending on the outcomes of the experiment, and to each of whose value a probability assignment can be made, is known as random variable. A discrete probability distribution counts occurrence that have countable or finite outcomes. This is in contrast to a continuous distribution where outcomes can fall anywhere in the continuum. Common example of discrete distribution includes the binomial, Poisson, and Bernoulli's distribution. We will see how these are applied in probability, and that too in probability distribution. A discrete probability distribution function has 2 characteristics. Each probability is between 0 and 1 inclusive, and the sum of the probability is 1. Discrete events are those with a finite number of outcomes, that is tossing dice or coins. For example, when we flip a coin, there are only two possible outcomes, that is head or tails. When we roll a 6-digit die, what are the numbers possible? 1, 2, 3, 4, 5, 6. Correct? It is computed by using the formula summation mu is equal to summation x into px. Now we will see what does all this mean. The variance is denoted by sigma square and standard deviation is denoted by sigma of a discrete random variable x are numbers that indicate the variability of x over numerous trials of the experiment. Now see, this is how it is written. Probability distribution of heads is 0, 1, 2, 3. These are the discrete values, and random variables is number of heads in the toss of the coin. What we are getting in decimals is the probability distribution or respective probability. When you are going to add up all these four values, you will get one. Let's see how it comes. How it is written. A description giving the value of random variables along with the corresponding probabilities is called probability distribution of the random variable. Random variable of x will take the values of x1 till xn, and the respective probability will be px, that is p1, p2, p3 till pn. For each probability distribution of x is defined only when p1 is greater than equal to 0. तो आपका पी आई का समेशन जो हो जाएगा जब आप सबको ऐड करोगे, इट विल कम आउट टू बी 1. Now how mean is calculated? Mean is product of xi pi. Variance is summation of x square pi minus mu square, and standard variance is defined as expected value of the square of the random variable and its expected value. Actually वो कहाँ से आए? Find the mean, variance and standard deviation of number of heads when 3 coins are tossed. First of all, calculate sample space. Coin है, coin में head और tail होता है, correct? कितने coin है? 3 coin है. 2 raised to power 3 कितना हो गया? 8. अब 8 sample space होंगी. 3 heads, TTH, THT, HTT, THH, HTH, HHT, and all the 3 heads. These are 8 in number. So NS is equal to 8. X with the number of heads in tossing up a coin. जब आप ये सब coin toss करेंगे तो what number of heads will be? No head, 1 head, 2 head, or all the 3 heads. The possible values of X will be 0, 1, 2, 3. When we have to find out the probability of X is equal to 0, that means no head. No head means all the 3 will be tail, 1 by 8. X is equal to 1, that is 1 head. See from the sample space how many 1 heads are there. Only 1 head. Only 1 head are there. There are 3 cases where only 1 head is there. X is equal to 2, that means 2 heads are there. Again, there are 3 cases, that is 3 by 8. And probability of getting 3 heads. 3 head will come in 1 space, 1 by 8. जरा इन सारी probabilities को आप add कीजिए. 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. How much it is?
After adding all the
1 by 8.
values, it's equal to 1.
That means mathematically it is correct. This has been taught to you that the sum will be equal to 1. I have proved sum is 1. I have to find out mean, variance, standard deviation, everything has to be calculated. Now This data is being converted into the tabular form. Here it comes. X is equal to 0, 1, 2, 3. Pi is 1 by 8, 3 by 8, 3 by 8, and 1 by 8. We have to calculate mean. So we have to multiply these two plus multiplication of these two plus multiplication of these two plus multiplication of this 2. We get 3 by 2. For calculating variance, V sigma square is equal to x square pi minus mu square. So we have to multiply x 0 square into 1 by 8 plus 1 square into 3 by 8 plus 2 square into 3 by 8 plus 9 square by 1 by 8. So here it is written minus mu square. Mu square is 3 by 2. 3 by 2 whole square, which comes out to be this. So it comes out to be, after calculation, 3 by 4. You have to calculate standard deviation under root this 3 by 4, which comes out to be root 3 by 2. And root 3 is 1.7. 1.7 divided by 2 is 0.8.
सर ब्रैकेट थोड़ा सा इसमें गड़बड़ लग रहा है क्या अंदर में, सिग्मा के अंदर में?
How come?
सर एक्स आई स्क्वायर पी आई सम हो रहा है सिर्फ सर, म्यू म्यू स्क्वायर तो जो है वो अलग है.
हाँ, म्यू स्क्वायर तो बाहर ना, किसके अंदर भाई? म्यू म्यू तो ये है, 9 by 2 का स्क्वायर करूंगा तो 9 by 4 नहीं आएगा.
नहीं, फार्मूला उसके ऊपर जो फार्मूला लिखा हुआ है वो उसमें ब्रैकेट में रखा हुआ है सर. वो एक एक यूनिट में जो है वो म्यू स्क्वायर तो उस तरह से 4 बार ऐड हो जाएगा सर.
हाँ, वो वहां से हटेगा, वो हट जाएगा, वो वहां से हट जाएगा.
यस यस सर.
वो म्यू आगे रहेगा, वो ब्रैकेट जो आपका है वो आगे रहेगा.
जी जी.
ओके, स्टैंडर्ड डेविएशन भी आ गया. नाउ व्हाट नेक्स्ट हैज टू बी फाउंड? दिस कम्स बायनोमियल थ्योरम. बायनोमियल थ्योरम के लिए अब देखिए मैथमेटिक्स है तो इसमें तो एनीथिंग एंड एवरीथिंग इज बीइंग यूज्ड. अब मैं यहाँ पर आई हैव टू यूज परमिटेशन, अ कॉम्बिनेशन. Let there be n independent trials in an event and let the random variable x denote the number of success in these trials. Here you are aware of that p plus q is equal to 1. ये तो डिस्कशन कर ही रहे हैं कि probability of success is given by p and probability of failure is denoted by q. Summation of addition of some success, probability of success plus probability of failure is equal to 1. For binomial theorem, we have to apply this formula, what is written over here. Fr is equal to NCR, P raised to the power R, Q raised to the power N minus R. Now the question is how to solve this NCR. NCR is N factorial upon R factorial into N minus R factorial. Remember one thing, 0 factorial is 1, not 0. Zero factorial is what? 1. It is not 0. There comes the formula, respective formula, how to apply that in binomial distribution. 0, 1, 2, 3 till R, and the respective probabilities will be q raised to the power n, npn, np q raised to the power n minus 1, nc2 खुलेगा till ncr, p raised to the power r into q raised to the power n minus r. Now the thing is that where this Bernoulli's process is applied. Normally आपकी problem में तो never it is written कि it is by success or it has to be solved by Bernoulli's theorem or by Poisson theorem. Normally, typical examples of Bernoulli's process are coin tossing and success failure situation.
सर ये n/2c कैसे आ रहा है?
भाई आप जब उसको एक मिनट, NC1 क्या होगा?
factorial n divided by factorial n minus 1 by factorial 1.
और जब आप एन फैक्टोरियल को खोलेंगे तो फिर अगला टर्म क्या होगा, n इंटू एन माइनस वन फैक्टोरियल होगा, न्यूमरेटर डिनोमिनेटर से कैंसिल होगा, खाली n ही बचेगा।
जी अच्छा यहाँ से आ रहा,
हमने वो
ठीक है।
फॉर्मूला लिखा किस लिए, इसलिए तो लिखा है। Now see, what are the conditions for the application of Bernoulli's distribution? The experiment is performed with fixed number of trials and performed for finite trials. Each trial must give either a success or a failure, and the probability of success in each trial will be same. So in that case, your mean will be L into P sigma square, that is the variance, will be at NPQ, and your standard deviation will be under root of NPQ. Next is Poisson process and distribution. Poisson distribution is applicable to events occurring randomly over time and space. Represent distribution of several random variables, like to count the number of defects of a finished product, to count the number of deaths in a country by any disease or natural calamity, to count the number of infected plants in the field, to count the number of bacteria in the organism, or the radioactive decay in an atom, to calculate the waiting time between two events. These are normally the cases where Poisson distribution is applied. Now, what is the formula for Poisson distribution? This responds to the Bernoulli's process with a large number of trials and is tending approaching to infinity, and the probability of success is very low. In that case, we get a constant, that is m or lambda. Different books, different notification is being used. So m is product of NP, and r are the number of successes. So probability of r will be e raised to the power minus lambda into e raised to the power minus m into m raised to the power r upon r factorial. देखिए कौन सी प्रॉब्लम, हाँ, where what are the properties of Poisson distribution? The events are independent. The average number of successes in the given period of time alone can occur. No two events can occur at the same time. The Poisson distribution is limited when the number of trials n is indefinitely large. That means mu mean is equal to variance is equal to lambda, or m. NP is equal to lambda or m, which is a finite number and it's a constant. The standard deviation is always equal to the square root of the mean. Now we will see how it is used. If 3% of electronic units manufactured by a company are defective, that means probability of defective is 3 by 100. Find the probability that the sample of 200 units, less than 2 bulbs, are defective. Now the thing is that here you can see that probability is 0.03 and sample size is 200. That means n is approaching to infinity and probability is too low. So that means we have to calculate NP. NP is 200 into 0.03, which comes out to be 6. That means your lambda will be 6. Now we have to apply Poisson distribution formula, that is e raised to the power minus lambda into lambda raised to the power r upon x or x factorial. So we have to calculate less than 2 defective bulbs. So how it is written? Probability x less than 2. X less than 2 means no defective or 1 defective. That means probability of no defective plus probability of 1 defective. we will be calculating, putting this x is equal to 1, 0 and 1. So that is e raised to the power minus 6 into 6 raised to the power 0 divided by 0 factorial plus e raised to the power minus 6 into 6 raised to the power 1 upon 1 factorial. I told you 0 factorial is 1. And anything to the power 0 is also 1. So in first case, it will be e raised to the power minus 6 plus e raised to the power minus 6 into 6. So straight away we can write 7 e raised to the power minus 6. And the value of e raised to the power minus 6 will be given in the paper. That will, you have to simply multiply it. And the probability of x less than 2 will be 0.01729. This is how this particular problem is solved.
Sir, can we use a electronic calculator?
No. But why it is? Why you are asking for?
Sir, to calculate any logarithm or like.
Nah. You won't be getting the value of e raised to power minus 6 will be given to you in the problem, in the question paper.
Right, right.
Sir, calculator must be allowed. Otherwise, there may be calculations may be time consuming.
आप कोई प्योर मैथमेटिक्स का पेपर सॉल्व नहीं कर रहे हैं, कोई एक या दो प्रॉब्लम होंगी और ऐसी कोई कैलकुलेशन नॉर्मली इट्स नॉट आस्क्ड. कैलकुलेशन होती है कंसेप्ट की. Now comes continuous probability distribution. Variable of interest may take any value within a given range. This type of random variable, which can take an infinite number of values, is called continuous random variable. Probability distribution of such a variable is called continuous probability distribution. Normal distribution. A normal distribution is the most versatile of all the continuous probability distributions. It is found to be useful in statistical inferences, characterizing uncertainties, many real-life processes, approximating other probability distributions. What is a normal distribution in statistics? A normal distribution is a continuous probability distribution that is symmetrical around its mean. Most of the observation clusters around the central peak, and the probabilities for values further away from the mean taper equally in both the direction. आप बेल शेप देखा है आपने? बेल शेप डायग्राम दिखाया था मैंने आपको. That is of perfect normal distribution. And then the normal distribution, what happens? In normal condition, what happens? Not distribution, in normal conditions, we assume that mean is equal to mode is equal to median. Now, what are the properties of distribution? PDF of normal distribution is given by this formula. Minus infinity is on the left side and plus infinity is on the right side. Real world phenomena that actually form a normal distribution. First, birth weight of babies, height of males, blood pressure. These are the normal examples. What are the properties of normal distribution? Some of the important properties of the normal distribution are: in normal distribution, mean, mode, median are equal. Number one, the total area under the curve should be equal to 1. That is, probability on left side is 0.5 and probability on right side is 0.5. When you are adding 0.5 plus 0.5, you will get 1. The normally distributed curve should be symmetrical at the center. तभी वो bell shape बनेगा. Therefore, should be exactly half of the values are to the right of the center and half of the left of the center. Area under the normal curve. The plot of fx versus x gives the normal curve, and the area under the curve gives its probability. The normal distribution is symmetrical about the mean, and the area of each side is 0.5. 0.5 on the left, 0.5 on the right. The empirical relation states that 99.7% of the data observed following a normal distribution lies within three standard deviations of the mean. Under this rule, 68% of the data falls within one standard deviation, 95% within the two standard deviations, and 99.7 within the three standard deviations of the mean. Now comes the basic formula. The formula for calculating Z score is Z is equal to X minus mu upon sigma, where X is the raw score, mu is the mean population which will be given in the problem, and sigma standard deviation. Again, it will be given in the problem. The basic formula is Z is equal to X minus mu upon sigma. X is your score, mu is your mean, and sigma is your standard deviation. Normal distribution describes continuous data which have a symmetrical distribution with the characteristics bell-shaped. You see, bell-shaped. Binomial distribution describes the distribution of binary data from the finite sample. Now comes the application. A radar unit is used to measure speeds of car on a motorway. The speeds are normally distributed with mean of 90 kilometers per hour and a standard deviation of 10 kilometers per hour. What is the probability that a car picked at random is traveling at more than 100 kilometers per hour? Now the question arises how we will see that this is a problem related to normal distribution. Here, anywhere in the question it is mentioned it is normally distributed.
Yes, sir.
If it is mentioned in the problem, move to the concept of normal distribution. Now, concept of normal distribution is you have to find, you should be aware of mu, that is the mean. Is that given in the problem?
Yes, sir.
Yes, sir.
For Z score, you need standard deviation. Is that given to you?
Yes, sir.
Yes, sir.
That means this is a confirmed case of normal distribution. What you are supposed to calculate, probability X greater than 100, correct? Your
Yes,
X
sir.
is, your X is 100, your basic score is Z is score minus mu upon sigma. 100 minus 90 divided by 10 is 1. Okay? That is the thing. P Z greater than 1. That is total area minus area on the left of Z is equal to 1. This area of the left of Z will be given to you in the problem. The value that is 1 point, that is 0.8413 will be given provided to you in the problem, in the question paper. Straight away you have to calculate 1 minus total area minus 0.8413, which comes out to be 0.1587. Keep one thing in mind. While solving a problem of probability, your answer should always be less than 1. If it is coming more than 1, have a relook at your solution. Probability of any event cannot be greater than 1, nor greater than 1, or nor it can be in negative way. What are the characteristics of standard normal distribution? A
Sir,
Z
sir, previous question, whether graph or table will be given. Otherwise, how will we will be knowing that what is the area in the left of the that thing? How can we know?
देखिए एक बात बताइए मुझे इनकम्प्लीट इंफॉर्मेशन क्वेश्चन पेपर में देकर is there any charm in asking up a question? Everything will be provided to you. If you are much more worried, my submission is that you should go through the previous semester question paper that are available on the university website, and that will be easier for you to understand. Everything is provided in the question. Every value, whatever is required, is provided in the question paper.
सर ये जो एरिया टू द लेफ्ट ऑफ दैट जेड इक्वल टू 1, ये चीज समझ में नहीं आ रहा सर, इसको थोड़ा सा इलेबोरेट कीजिए
अभी अभी न्यूमेरिकल प्रॉब्लम आने दीजिए, आपको अपने आप समझ में आ जाएगा
सर।
ये तो मैं सिर्फ आपको थ्योरी समझा रहा हूँ, इसलिए आपको थोड़ा सा लगा। अभी मैंने जेड स्कोर की बात की थी ना, अब मैं जेड स्कोर की आपको सारी कंडीशन बता रहा हूँ, तो आपको भी अपने आप क्लियर हो जाएगा। A Z score of a standard normal distribution is a standard score that indicates how many standard deviations are away from the mean and individual value X lies. Number one, when Z score is positive, the X value is greater than mean. When Z score is negative, the X value is less than mean. And when Z score is equal to 0, the X value is equal to mean. Now we will see. The score tell us how many standard deviations are away from the mean. Each value lies. लीजिए देखिए, ये है वो नॉर्मल डिस्ट्रीब्यूशन का ग्राफ जो फ्री हैंड बाय हैंड ही बनाया जाता है। इस ग्राफ की एक प्रॉपर्टी है कि जो ब्लू लाइन आप देख रहे हैं, दैट नेवर टचेस हॉरिजॉन्टल लाइन। लेफ्ट साइड में सेंटर में आपको 0 दिख रहा होगा, राइट साइड में +1 दिख रहा होगा, +2 दिख रहा होगा, +3 दिख रहा होगा, और लेफ्ट साइड में यू कैन सी -1, -2, -3। सेंटर लाइन है, इसके लेफ्ट साइड का जो एरिया है दैट इज 0.5, और इसके राइट साइड का जो एरिया है दैट इज 0.5। जब मैं इन दोनों एरिया को कंबाइन करूंगा तो टोटल एरिया आएगा दैट इज 1। नाउ सी, usually happening in the real world follow a normal distribution. This enables researchers to practice normal distribution as a model for evaluating probabilities linked with the real world scenarios. Basically, the analysis includes two steps: converting raw data into the form of z-score using the conversion equation z is equal to x minus mu divided by sigma, finding the probability after the raw data is transformed into z-score, then with the help of standard normal distribution table or normal distribution calculators available online to find probabilities linked with the z-score. Finding the how the find probability is found after the raw data is transformed into z-scores, then with the help of standard normal distribution tables, we calculate z-scores. Now see the problem. For some computers, the time period between charges of the battery is normally distributed with mean of 50 hours and standard deviation of 15 hours. Achal has one of these computers and need to know the probability that the time period will be between 50 and 70 hours. Now see, mean is 50 hours. Standard deviation is 15 hours. And you are being asked to calculate the probability between 50 and 70 hours. First of all, from this data, we will find out z-score. Mu is 50, given in the problem. Sigma is 15, given in the problem. You have to find the probability that x lies between 50 and 70. So mathematically, it is written as probability 50 less than x less than 70. You have the formula for transformation equation z is equal to x minus mu upon sigma. For x is equal to 50, you get 0. For 70, you get 70 minus 50 upon 15, that is 1.33. Okay. Now see. Your question was probability 50 less than x less than 70. it has been transformed to probability of in terms of z. Z score has been calculated. So 0 less than z less than 1.33. That means area on the left of 1.33 minus area on the left of 0. यही होगा. ग्राफ फ्री एंड बना, इसकी वैल्यू आपको पेपर में गिवन होगी. For probability of z is equal to 0 is 0.5 and probability of 1.33 we will give provided you in the paper. That comes out to be 0.9082 minus 0.5, which is 0.4082. That means the probability that Achal's computer has a time period between 50 and 70 hours is equal to 0.4082. If I multiply this by 100, so it will be in terms of percentage. That means 40.82%. The battery's life will be between 50 and 70 hours. This graph is drawn by freehand only. Now another problem is there. Most graduate schools of business requires applicants for admission to take Graduate Management Admission Council's GMAT examination. The scores on the GMAT are roughly normally distributed with mean of 527 and standard deviation of 112. What is the probability of an individual scoring between 500 on the GMAT? What will you do? I have drawn everything on this graph. Your mean was 527. You were asked to find out, calculate the value of 500. No doubt it will be on this side. You have to calculate z square. Z square is z score. That will come out to be 0. Minus 0.24. Yeah. Now it is okay. This is how a normal distribution problem is solved. Mu is given to you, sigma is given to you. You have to calculate at 500. 500 minus 527 divided by 112. This comes out to be negative 0.24107. Probability has to be x greater than 500. So it will be z greater than minus 0.24. Greater than हो गया तो आपका 1 minus 0.4052. That is the standard value of z value at negative 0.24. So that means your answer is 0.5948. The value of z will be provided to you in the problem. Another problem. Average number of acres burned by forest and range fires in a large New Mexico country is 4,300 acres per year and a standard deviation of 750 acres. The distribution of the number of acres burned is normal. What is the probability that between 2,500 and 4,200 acres will be burned in any given year? Again, I have drawn the complete conversion on a single figure. 4,300 is the mean. You have to calculate for two values, that is 4,200 and 2,500. So these values have been, that means you have to calculate this area. This is This is how it is calculated. Since X has two values, 2500 and 4200, so individually it has to be calculated. So for 2500, Z will be minus 2.40, and for 4200, it will be negative 0.13. The problem was to find probability of 2500 less than X less than 4200. Convert it into Z. This comes out to be probability negative 2.40 less than Z less than negative 0.13. How this will be done? Because probability on the tabular value for the left side is this one, and the tabular value of the left side is given to you as this one. We have to find this from the, we will be subtracting the value of negative 2.40 from value of Z equal to 0.13. These are the values, and after subtracting we will get this. That is the graphical level what you have to draw. Then only, first of all, you have to calculate this part. Then you have to draw a bell-shaped curve. सेंटर लाइन पे आपका मीन आ जाएगा. लेफ्ट साइड में 4200 है तो वो इधर जाएगा, 2500 है तो इधर आएगा, 43 से ज्यादा होता तो इधर आता. अब इन दोनों के बीच का एरिया, यू हैव टू फाइंड दिस एरिया इन बिटवीन दिस. दिस इज द वे हाउ इट इज रिटन. And the value of Z at 0.13 and the value of Z at 2.40 will be given to you in the problem. Now, exponential distribution is found to be useful for characterizing certainty in machine life, length of telephone calls, etc. Normal distribution is found to be useful for characterizing dimensions of machine parts, heights, and weights. Now comes the decision theory. What we mean by decision theory, what we are going to get. As initially it was told that probability, we use probability in making decisions. You might have seen the best example of nobody knows how this cricket pitch is going to behave in tomorrow's match. By the past record, we see that this is how policies are made. So similarly over here, it depends upon the probability. A necessary condition for the existence of a decision problem is the presence of alternative ways of action. Each action leads to a consequence through a possible set of outcomes, the information on which might be known or unknown. One of the several ways of classifying decision problem has been based on this knowledge about the information on outcomes. How this classification is made. Decision making under certainty. That means we're confirmed. The information on outcomes are deterministic and are known with certainty. And decision making under uncertainty. The information on outcomes are probabilistic with the probabilities known or unknown. Depending on the planning horizon under consideration, as also the nature of this decision, we have either a single state decision problem or a sequential decision problem. Marginal analysis and TT approach. Marginal analysis for solving such single stage problems. For sequential decision problems, the decision tree, that is DT, approach will be used. In both the marginal analysis and the decision tree approach, we will be using the expected profits as a criteria for our decision. Everybody wants profit. EMV, expected monetary value, does not take into account the decision maker's attitude towards risk. Preference theory provides us with the remedy in this context by enabling us to incorporate risk in the same setup. The other problem with expected monetary value is that it can be applied only when the probabilities of outcome are known. EMV, that is still continuing, this is marginal analysis, a technique widely used in business decision making and ties goes much of economic thought. In many situations, people want to maximize net benefits, and net benefit is total benefits minus total cost. The analysis of the benefits and the cost of marginal unit of good or input is margin is equal to the next unit.
सर प्रेफरेंशियल प्रेफरेंशियल वाला थोड़ा हाँ प्रेफरेंस थ्योरी
What does this say? It provides us with the remedy in context of enabling us to incorporate risk in the same setup. We are talking in terms of probability. The other problem with expected monetary value is that it can be applied only when the probabilities of outcome are known. We are trying to calculate monetary benefit taking in terms of probability.
ओके
These all discussion today is going in terms of mathematics terms, not in actual theoretical part. It's application, how it is applied. What are the control variables? To do marginal analysis, we can change a variable. That is quantity of a good you buy, the quantity of output you produce, or the quantity of input you use. This variable is called the control variable. These can be controlled. Marginal analysis focuses upon whether the control variable should be increased by one more unit or not. What is the key procedure for using marginal analysis? Identify the control variable. Determine what the increase in total benefits would be if one more unit of the control variables are added. Determine what the increase in total cost would be if one more unit of the control variable were added. This is called the marginal cost of the add unit. It should be added. Now, remember, you look only at the change in the total benefits and total cost. If a particular cost or benefit does not change, ignore it. उसका कोई effect ही अगर if you don't find any effect, leave it. Your marginal benefit is equal to increase in total benefits per unit of control variable. That means change in total revenue upon change in quantity, which is equal to marginal revenue. CV is your control variable. The marginal cost is increase in total cost per unit of control variable. That is delta TC upon delta Q. CV is equal to MC. Change in net benefits is equal to marginal benefit minus marginal cost. Why does this work? When marginal benefits exceed marginal costs, net benefits goes up. So the marginal unit of the control variable should be added. How the problem formulation takes place. A decision problem is characterized by decision alternatives, states of nature, and resulting payoff. The decision alternatives are the different possible strategies the decision makers can employ. The states of nature refers to future events not under the control of decision makers which may occur. States of nature should be defined so that they are mutually exclusive and collectively exhaustive. Inference diagram. An inference diagram is a graphical device showing the relationship among the decisions, the chance events, and the consequences. A square or rectangles depicts decision nodes. Circle or ovals depicts chances nodes. Diamond depicts consequences nodes. And lines or arcs are the connecting nodes that show the direction of influence. Payoff table. The consequence resulting from a specific combination of a decision alternative and a state of nature is a payoff. A table showing payoff of all the combinations of decision alternatives and states of nature is a payoff table. Payoff can be expressed in terms of profit, cost, time, distance, or any other appropriate measure. Then comes your decision tree. A decision tree is a chronological representation of the decision problem. Each decision tree has two types of nodes: round nodes, which corresponds to the state of nature, while square nodes corresponds to the decision alternatives. The branches leaving each round node represents the different states of nature, while the branches leaving each square nodes represents the different decision alternatives. At the end of each limb or of a tree, there are payoffs attained from the series of branches making up that limb. Decision making without probabilities. Three commonly used criteria for decision making when probability information regarding the likelihood of the states of nature is unavailable are optimistic approach, second one is conservative approach, the third one is minimax regret approach. Optimistic approaches would be used by an optimist decision maker. The decision with the largest possible payoff is chosen. If the payoff table was in the terms of cost, the decision with the lowest cost would be chosen. And conservative approaches, the conservative approach would be used by the conservative decision maker. For each decision, the minimum payoff is listed and then the decision corresponding to the maximum of the minimum payoff is selected. Hence, the minimum possible payoff is maximized. With this, I will be concluding today's session. Any one of you have any query, you may ask me.
Sir, any probable suggestive question you will recommend, or portion which are important for exam purpose?
Just now we have a discussion on probability conditions. So, in which in which terms of probability you want me to answer it? Optimistic, pessimistic, or probabilistic?
Sir, probably.
But, what is the condition of probability? Tomorrow it may rain or it may not rain. Who knows?
Sir, conservative.
Concentrate on the text. That will be helpful to you. And for exposure purpose, I would suggest that you should go through previous terms examination question papers. These are available on the university website and there's a download section. That will be easier for you to understand and prepare your paper. And there you can see what type of problems are asked and what is the condition, how they have to be performed. I'm no doubt I'm teaching you the most probabilistic part because this is a very short period of time. So I have to tell you, make you comfortable with the subject as far as to the best of my ability.
Thank you, sir.
Okay, any other question from anyone? Should we conclude today's session?
Yes, sir.
Thank you. See you tomorrow.
Good night, sir.
Good night.